specimens. These are microscopic specimens. Don't even try to understand it. But you see the difference. Here it's lightly, you don't see any color here. You see the cells, these are the cancerous cells. And here you see heavy staining with a brown color. We did the brown color. We took the same brown color and we painted this one and this one. But only this one was painted. This one was not painted. This means that the painting was able to catch up. This is an antibody painting. I don't want to go into details. That this woman has something that this woman doesn't have. This woman has an estrogen receptor in the breast tumor, and this tumor does not. Therefore, this woman can be treated with tamoxifen, which is an anti-estrogen receptor. The estrogen receptor for this woman leads to progression of the cancer. But this woman has something else, but not estrogen receptor. So if I treat this woman with tamoxifen, she may be cured. But if I treat this woman with tamoxifen, nothing will happen because she doesn't have an estrogen receptor. So I have to treat her. For this woman, I have to find something else. But I treat the same woman with the same size fits all. I buy the same woman a medium-sized pajama. But this woman cannot be helped by a medium-sized pajama. She needs something else. She needs an exactly tailored pajama that has rosy flowers on them, because otherwise she will not be helped. This is called molecular medicine. I have to develop better spectacles in order to diagnose the two. Now I bring you an example of the beginning of the road. This trick I know already, the estrogen receptor. But this also is not sufficient, because what will happen is the following. So in this case, I know what's the difference. But if I look at the general population, this is the picture that I get. If I take 100 people, 100 women that have breast cancer, you see that they are painted here with green, with blue, and with yellow. The problem is that I'm colorblind. Not me in person. Medicine is colorblind. Medicine doesn't see that this guy is yellow, and this guy is blue, and this guy is green. We take all of them, and we treat them the same. We irradiate them. We give them chemotherapy. We cut the tumor away. After 5 years, these people are cured, but this one are dead. Because I couldn't see at the beginning that this one is yellow. What I want to do now is to develop tools, better spectacles, that will tell me exactly who is yellow, who is blue, and who is green. So I will not buy one pajama to all these 100 people. I will buy to this one medium, to this one large, and to this one small. And actually, within the small, I will have number 20, number 22, number 24, number 26, like shoes. I will go by half numbers. I will tailor it exactly as if I go to a high top, to a top-notch Milanese fashion tailor and do it exactly what fits this woman. I will not buy 3 pajamas for all the 100 patients. Now, how do I do it? I do it by DNA sequencing. And here it is. You see, it's not me, it's Time magazine. Time magazine devoted a lot of articles into it. You see here, the man and the woman are surrounded by this serpentine of the DNA. If you'll go to San Rafael Hospital, to the new building, you will see this double helix hang there as the symbol, the heart of life. It's a beautiful sculpture, Maria Garcia, just wonderful. And based on the DNA that you see here, the double helix, new drugs will come out. Now, how they will come out? Let me explain you this one, and then I'll explain you a little bit about the bioethical problems, and we'll end up with this. So we are in the third revolution. We are going to sequence the human genome. What does it mean? You will tell me, probably most of you will tell me, what are you talking about? The human genome was sequenced already. At the beginning of the century, everybody talks about the human genome. Yes, one human genome of one single human being by the name of, doesn't matter whom, Bob Solomon, was sequenced. But we are going now to sequence the human genome of each and every one of you. Well, don't take me too seriously. I'm not going to force anything. It will have to go via lots of legislation. There are many problems. But let me put it in different words. This is the way to get from one size fits all to personalized medicine. So the one single human genome that was sequenced took 10 years and about several $1 billion to do. In 5 years only, we shall be able to sequence the human genome, and I'll tell you in a minute what it is, in about 15 minutes, a whole human genome that contains 3 billion letters. We'll go into the human genome in a minute, for a cost of less than $1,000. Now, $1,000 is about the cost of an MRI or a CAT scan. It's going to be a routine laboratory test. Now, what is the human genome? Without going into details, the human genome is the library of information that make us what we are. It makes me, Aaron Chikanover, and it makes you, Gianvito, and you, Maria. There are many things that are common to us. We have 2 legs, we can see, we can even talk, but it makes us also very different from one another. If, lo and behold, I will need a kidney, I will not be able to get it automatically from Maria Garcia because we don't match immunologically. So we are different in our proteins. She cannot give me a kidney and I cannot give her a kidney unless we are making a pre-test to see that we are matching. We are not talking even kidney. She doesn't even can give me a blood. We have to match even in our blood. Blood is easier because there are only 4 groups and some subgroups. There is an A and B and AB and O. So blood is easy, but I cannot automatically, no way in the world that I can automatically make any blood transfusion among the people that are sitting here. I need to test my blood and the blood of the acceptor, and only then, once the blood groups are matching one another, I can do it. So despite the commonalities, we are very different from one another. We are human beings. She speaks Italian, I speak Hebrew, but we can communicate in English. So there are many common denominators between the 2 of us, but nevertheless, we are very, very different, even in the physique of us, in the basic structure of the body. So that means that her DNA is different than mine, because it codes for different proteins. Her body will reject my kidney and the opposite. Her body will not take my blood unless it matches, because her DNA codes for different blood group than mine. Therefore, it's necessary that I will understand the entire information that is embedded in each and every one of us. Now, what that has to do with pajamas and cancer? It has to do a lot. Because this exactly will be able to tell me why one woman died and one woman lived. And let me just go to this woman again, and you have to really implement it and understand it. If these women are intelligent women, or courageous, or even if they are not courageous, but their husband and the families are courageous, or they just want to know, after the woman leaves the clinic, the husband or the son or whoever will ask the doctor, "Doctor, tell me, what are the chances of my wife to make it through? Or what are the chances of my mother to make it through?" The doctor will say 70%, 80%, 50%, 10%. What does it mean 10%? What does it mean 50%? This is Las Vegas? 50% is gambling. It means that 50% she will die, or 50% she will live. For cancer, it's 5 years. Oncologists typically talk about 5 years. But what does it mean, 50%? Will my mother live or die? The doctor will say, I don't know, it's 50%. 50% means that out of 100 women, 50 live and 50 die. That's all what it means. But he cannot tell you that your mother will live or die. He will tell you that his experience and the experience in the literature, scanning for 10,000 women in this situation, showed that after 5 years, 5,000 women are buried in a cemetery, and 5,000 women are taking their kids to school every day. That's all what he can tell you. This is gambling. This is not science. This is not biology. We want to take, scientists and physicians, want to take this woman out of the Las Vegas game and bring them back to science. Now, I don't care about the woman that will live. I'm happy for her.